In this video, we'll learn how to solve equations involving inverse trigonometric functions. Here's an example. 2 tan inverse cos x is equal to tan inverse 2 cosec x. So we need to figure out the values of x for which this statement is true. Pause the video, try this out. Okay, let's do this together. In problems like these, we can start from one side. This left hand side is twice of this angle, tan inverse cos of x. Let's assume that this angle is theta. Let's assume tan inverse cos of x is equal to theta. If we take tan on both the sides, we get tan of theta is equal to cos of x. So that's just a relation between theta and x. Tan theta is equal to cos of x. But what do we need? We need twice of this angle. And twice of this angle is equal to tan inverse of something. So if we take tan of the left hand side, tan of 2 theta, we get twice of cosec x. So what we need is tan of 2 theta. So let's figure that out. Tan of 2 theta, that's equal to 2 tan theta by 1 minus tan square theta. We can apply this identity. Here we can substitute tan theta with cos x. This becomes 2 cos x by 1 minus cos square x. This denominator 1 minus cos square x, this becomes sin square x. So tan of 2 theta, that's equal to 2 cos x by sin square x. Now left hand side is 2 theta. Tan of the left hand side is equal to 2 cosec x. So we can eliminate theta here. We can write this as 2 cosec x equals to 2 cos x by sin square x. Now this is an equation in x and we don't have any inverse function here. So now we can solve. 2 cosec x is 2 upon sin x. That's equal to 2 cos x by sin square x. 2 cancels out. Sin x and sin x cancel out. We have a sin x upon cos x is equal to 1 or tan x is equal to 1. So we're looking for the values of x where tan x is equal to 1. That's pi by 4, that's the principal value. But the general solution is n pi plus pi by 4, where n is an integer. So the solution for this equation is x equals to n pi plus pi by 4. For all of these values, this statement will always be true. Let's try one more. Tan inverse 1 minus x by 1 plus x equals to half of tan inverse x. Pause the video, try this out. Okay, let's do this together. Here, right hand side looks simpler. Let's assume tan inverse of x as an angle. Let's assume that is equal to theta, which means tan of theta is equal to x. Now let's use this on the left hand side. Tan inverse 1 minus x by 1 plus x, that's equal to tan inverse 1 minus x here is tan theta. So 1 minus tan theta by 1 plus tan theta. Now we need to write this in terms of tan so that tan inverse and tan can talk. This is 1 minus tan theta by 1 plus tan theta. This is tan pi by 4 minus tan theta by 1 plus tan pi by 4 tan theta. We can replace 1 with tan pi by 4. This becomes tan of pi by 4 minus theta. So this becomes tan inverse tan of pi by 4 minus theta. Tan inverse and tan cancel. This becomes pi by 4 minus theta. So this left hand side is pi by 4 minus theta. And what's right hand side? That's half of tan inverse x. This means that's half of theta. So now we have an equation in theta. We can solve this. Theta plus theta by 2, that's 3 theta by 2, that's equal to pi by 4. 2 cancel out. 3 theta is pi by 2 or theta is pi by 6. And when theta is pi by 6, what's the value of x? X is tan theta. So x is tan pi by 6. Tan pi by 6 or tan 30, that's 1 by root 3. So x is equal to 1 by root 3. One last problem. Sin inverse 1 minus x minus 2 sin inverse x is equal to pi by 2. Pause the video, try this out. Okay, of these two, sin inverse x looks simpler. Let's start with this. Sin inverse x is equal to theta. This is an angle. We have assumed that this angle is theta. This means sin of theta is equal to x. So let's evaluate sin inverse 1 minus x. This minus 2 theta is equal to pi by 2. Taking 2 theta to this side, we have sin inverse 1 minus x is equal to pi by 2 plus 2 theta. Now to get rid of this sin inverse, we can take sin on both sides. Sin on both sides will give us 1 minus x on the left hand side and sin of pi by 2 plus 2 theta on the right hand side. Sin of pi by 2 plus anything is cos of that thing. So this becomes cos of 2 theta. Now we want cos of 2 theta in terms of x. We have sin theta in terms of x. So which identity can we use? We can use cos 2 theta is equal to 1 minus 2 sin square theta. So right hand side becomes 1 minus 2x square. Now we have an equation in x, we can solve this. 1 cancels out, 2x square minus x is equal to 0. Taking x common, we have x times 2x minus 1 equals to 0. Either x is equal to 0 or 2x minus 1 is equal to 0. This gives x is equal to half. So the solution for this equation is either x is 0 or x is half.